Okay, so example 1 says a sample survey is designed to estimate the proportion of sport utility vehicles being driven in the state of California. A random sample of 500 registrations is selected from the Department of Vehicles database, and 68 are classified as sport utility vehicles. We're going to use a 95% confidence interval to estimate the true proportion of SUVs in California. When I start one of these, I always start by, zoom this out so you can see. I start by dividing into 4 spaces what I'm going to do. That way you make sure you don't forget anything. So I'm going to name my test, check my conditions, do the math, state the conclusion. I always do it that way, and whenever I'm grading these, you'll see out to the side of each problem one of these little chart things, and I'll put the letters in each one for how did you do on that part. Okay? So that's the way I always set it up. I'm not saying you can't just list them, but I've found if you list them out, sometimes you leave out a step, where if you're leaving something blank, that catches your attention, so you're like, oh yeah, I forgot to do that part. So, I don't know. To me, it kind of helps to draw it out this way. So, first thing we're going to do is name what test we're using. So, in this one, are we dealing with means or proportions? Proportions, right? Because we're finding the true proportion. So, what type of test does that mean I'm using? What kind of interval? There we go. So, we're doing a 1 sample interval for proportion. So, a Z interval. That's what we need to write over here for identifying the test. So we're going to do a 1 sample for proportions, or you can just do a 1 proportion Z interval.
We don't have to do 1 sample Z interval for proportions?
Either way, it's fine. As long as you put proportions in there and there's only 1 and it's a Z interval, if you have all that information, you're good. Now, do I have degrees of freedom for a Z interval? No. Okay. What else do I need to include over here in this first box? The parameter. I need to define what that parameter is. Good job, Thomas. So, what letter do we use for the parameter? P. Good. True. California, better issues. Okay, are we good with that first box? Name the test, define the parameter. That's all you have to do. You're done with the first box. Now we need to check conditions. So there are 2 conditions. We need to check for good enough data, so that's our randomization, and then we want to check for the sample size or normality. So we want to know, is it random? So did it say anything up here in the problem about randomly doing this? Yeah. So it tells us it's a random sample of 500 registrations. So the best way to show that you checked it is to write down that this is what it says. So we have a random sample of 500 registrations. It's safe. So that shows that we checked it, and this is how we know it's okay. Then our other condition is the large enough, or the sample size or normality, or however you want to look at that. I usually just say, is the size good enough? So if we're dealing with proportions, how do we check sample size? What? Right. we want at least 10 successes and 10 failures. Okay, so here, success is defined as an SUV. We want to know how many SUVs do we have. So we want at least 10 SUVs and at least 10 that are not SUVs. So here, we had 68 that are SUVs. So 68 SUVs. So that leaves how many that are not? Out of 500, we had 68 that are.
432.
So 432 are not SUVs. And both are greater than or equal to 10. So we're good. So both conditions are met. Any questions on checking conditions? Okay. Then we get to our do the math. So for proportions, we have p hat plus or minus our z critical value, and then our standard error is this. So I'm going to walk you through how to plug in the numbers and get it, and then I'll show you on the calculator how to do the same thing. Because sometimes they don't give you everything you need to do it on the calculator. They'll give you part of it, and you're having to use the formula. So I want you to see doing one with the formula. So p hat is what happened in our sample. So in our sample, we had 68 out of 500. So that's the SUVs in our sample. For our Z critical value, we're going to look on our blue sheet. Here's our T distribution. I'm going to look all the way down here at the bottom at the infinity line. And I'm wanting a 95% confidence interval, so I go to 95%, and that number is 1.96. That's my critical value. That's the Z value that I use. Okay? So 95%, there's my value. So this is going to be 1.960. Then over here, my p hat is still the same value. So 68 over 500. And then this one was 432 out of 500. So when I type this in my calculator, I type it in just like that. So when I see that on my paper, that's what I type in. We're going to have to do plus or minus, so I did the minus first because I want to list these. When I write my interval, I want the smaller number first and then the larger number after that because this is interval notation. So you just enter it exactly how you wrote it. There's my small number, and then you can go up and then just go back and change that minus to a plus instead of retyping everything. So those are my two values. Okay. Those are my two numbers. Now, if I'm going to do this just on the calculator, I would go to Stat and then over to Test. And then for the Z, I go all the way down, or you can just go up, maybe shorter, to 1 prop Z int. My X is how many SUVs did I have in my sample, so that's 68. N is what is my sample size, 500. I want a 95% confidence interval, so I leave that 0.95, and then just calculate. Anything you're typing in here needs to be written on your paper. If you're doing this on the calculator, you need to write down what you enter, and then write down what it gives you as the output. So then I would write down these values as my output. So you're going to see same values.
What's the 0.836?
That's p hat as a decimal. That's the 68 over 500 as a decimal. Anyone else questions on the math process? Okay, so the last step, we're going to write a conclusion. So, we are 95% confident that the interval from this value to this value, so the two values that we had in our confidence interval, contains the true proportion of SUVs in California. And this context, you can go back up to what the problem asked you to do. We're estimating the true proportion as for utility vehicles in California. That's your context. So it should always tell you, whenever you're creating the confidence interval, it should give you the context right there that you can use in your conclusion. Any questions on the process? Does it feel a lot like the hypothesis test that we did? Good. Hoping it will feel very similar to that. Okay, so what I'm going to have you guys do, I want you in your groups to finish this up, and then there's one on the back on means. Work through that one. And then you guys didn't get finished with these yesterday, so you did all four of both sides? Lies. I know for a fact you didn't. You only did one of the back side, so don't lie to me. That just told me I can't trust you.
I already told you I'm not going to study every street.
I know. I cried all night over that one. So, finish this up in your groups. These will be up here so you can finish those. Actually, I'll set some on each of these tables that nobody's sitting at. That way you can finish those up as you finish this. Okay? Don't forget your problem set. So you can do that. Hopefully you'll get it all done and not have anything to do over the weekend, because we all know Josh won't do it on the weekend.
Hey,